Hi everybody, in this video I am going to be talking about function transformations using negative reflections of graphs of functions. So, in earlier parts we have covered vertical shifts and horizontal shifts of graphs of functions. In this video we are going to talk about negative reflections of graphs of functions, and to understand what that means, let us take a look at our first example here, which says given y equal to f of x, draw y equal to minus f of x. So, we have this graph here of some arbitrary function f of x, and using this we have to draw the graph of y equal to minus f of x. In other words, we have to transform f of x to minus f of x, and that is what we have to do here. So, once again it is actually very helpful to think of functions as machines. So, think of your original function f of x as some machine f, and let us say that for some input x naught it produces the output y naught. And now what I want you to think about is what will happen, or how will this input output pair x naught y naught transform if the function transforms from f of x to minus f of x. And it is actually very straightforward to see. If our new function is minus f of x, then what do you think will happen if we put in the same input x naught into this machine? Now, because the original machine is producing y naught as the output, the new machine will produce minus y naught as the output, and therefore, the original input output pair x naught comma y naught will transform into the new input output pair x naught comma minus y naught. And graphically what this means is, let us take any point on this original function. Let us take this point here and suppose that this is x naught y naught. Then this point will transform to the new point x naught comma minus y naught for the graph of this function, and x naught comma minus y naught is simply this point reflected in the x axis, because your y coordinate is becoming the negative of its original value. So, this point will move to the mirror reflection or transform to the mirror reflection over here, which is x naught comma minus y naught, and actually the same thing is going to happen for every point on the graph. So, every point will transform to its mirror reflection. So, the points above the x axis will transform to the mirror reflections below the x axis, but the opposite will happen for points that were originally below the x axis. They will move above the x axis. So, for example, if you think of this point here, this point will move over here or transform to this point above the x axis. So, what is going to happen is this whole graph will actually get reflected in the x axis, and that is the transformation here, and here is what it is going to look like. I have drawn it for you using a graphing tool. This is the original function y equal to f of x, and this is the transformed function y equal to minus f of x. And you can see here that every point has transformed to its mirror reflection in the x axis. See this point here, this has gone or transformed to this point here. So, the whole thing has just reflected in the x axis to give us the graph of y equal to minus f of x. So, that is this case, y equal to minus f of x. But what if instead of minus f of x, we have f of minus x? Now, this is a very different case, because the negative sign is being applied not to f, but to the argument inside f. The negative sign is being applied to x in this case, and therefore, this is actually a very different case. And once again, thinking of functions as machines helps us understand this situation as well. Now, if you think of your original function f of x as a machine f, which takes, let us say, some input x naught to produce an output y naught, then this new machine, which is f of minus x, what does this do? How do you think about this machine? Well, it takes some input, it first inverts that input because we have a minus x here, and then it applies the function on top of that inverted value. So, this means that to get the same output y naught from this machine, what would you have to feed in as the input in this case? Well, you would have to feed in minus x naught here, because minus x naught will go into this machine, first get inverted to become x naught, and then the function will be applied on x naught, and therefore I will get y naught. So, the original input output pair x naught y naught will transform to the new input output pair minus x naught y naught. What does that mean graphically? So, let us take for example this point here, let us call it x naught y naught. So, this is a point on the original graph. Now, this point will transform to the new point minus x naught comma y naught. So, the x coordinate will get inverted in the transformation, and therefore, the new point corresponding to this will be a mirror reflection of this point in the y axis. So, this point here is minus x naught y naught, and so this point will move over here, and the same thing will happen for every other point on the graph. For every other point on the graph, the transformation will invert the x coordinate. So, for example, this point over here will actually move over here, and let us take a point over here, will move to the other side of the y axis. So, your whole graph should undergo a reflection in the y axis in this case, and let us see what that looks like. It looks like this. You have your original function y equal to f of x, and you have this new function, transformed function y equal to f of minus x, which is the original graph reflected in the y axis. And you can actually see that. So, let us see this point on the original graph, it has transformed to this new point on the new graph, or see for example this point over here, this has transformed into this point over here, and so on. So, you can see the inversion that has happened with respect to the y axis. So, that is f of minus x. So, let us summarize. If you have to transform y equal to f of x to y equal to minus f of x, you take the original graph and reflect it about the x axis. And why does that happen? Because any point x naught y naught on the original graph transforms to the point x naught comma minus y naught on the new graph. That is why the reflection is about the x axis, y naught is becoming minus y naught. So, the reflection is about the x axis. On the other hand, if you have the transformation from f of x to f of minus x, then the reflection is about the y axis. Why? Because any point on the original graph, let us take this point here x naught y naught, will transform to the new point, to the corresponding point minus x naught comma y naught, and therefore, the x coordinate is getting inverted, and so the reflection is about the y axis. So, these are the two possible cases of reflections. Okay, now using this, let us do a couple of quick questions. The first one says the graph of y equal to root of x is shown below. So, this is the graph of y equal to root of x. We have to draw the graph of y equal to minus root of x and y equal to root of minus x. So, in this case, you are applying the negative sign to the overall function. So, this is the case where you do minus f of x, whereas this is a case where you are making the argument itself negative. So, this case here is f of minus x. So, this one should be a reflection of the original graph in the x axis, and this one should be a reflection of the original graph in the y axis. So, let us quickly do that. Let me reflect the graph in the x axis. So, I should get something like, let me try and be a bit accurate. So, something like this, and this would be the graph of y equal to minus root of x. And now, let us plot the graph of y equal to root of minus x. So, you take this graph reflected about the y axis. So, you should get something like this, and this is the graph of y equal to root of minus x. Okay, this one is actually not root of minus x, this one is minus root of x. So, let me just rewrite this. So, this one is minus root of x. So, correction there, and this one here is root of minus x. So, once again the reflections are minus root of x is the original graph reflected in the x axis, and root of minus x is the original graph reflected in the y axis. Okay, so that's question number 1. And then question number 2, the graph of a function y equal to f of x is shown below. Draw the graph of y equal to minus f of 2 minus x. So this one seems a bit complicated. So let's kind of break it down a little bit. So what we can do is, from the graph of f of x, we can first draw the graph of f of minus x, and then what we can do is we can delay this graph by 2 units, or we can shift it rightward by 2 units. Why? Because that will give me f of minus of x minus 2, and if I open this thing here, this is nothing but f of 2 minus x. So, I get f of 2 minus x, and then I can finally apply a negative sign and get minus f of 2 minus x. So, the sequence of movements or reflections will be, first I reflect about the y axis to get f of minus x. So, let us actually do that. I will just reflect about the y axis, and that will give me something like, I am just drawing it as a dotted thing. So, something like this, that is great. Then I will delay this yellow graph by 2 units. So, let us do that. Let me delay it by 2 units, and then I should get something like this. And now this graph here, I should reflect it about the x axis because I want the negative of it. So, let us now reflect it about the x axis, and I am going to get something like this. So, let us see if I am doing this right. So, this point here is minus 2 4 should come to minus 2 minus 4, okay, and then I get this line over here, and then this thing here will reflect down like this. Okay, so I am getting this curve here, this function, the graph here like this, and then this, and then this. So, your original graph was the white lines over here, the white curve. You first reflected it about the y axis, then delayed it by 2 units, and then reflected it about the x axis, and that would give you the graph of minus f of 2 minus x. So, we combined 3 different transformations here to get our answer. So, that covers negative reflections. I hope you understood the concept, and I hope you liked it as well. Let me know what you think in the comments.